So welcome everyone. My name is Nathan LeClaire and I work for Docker Inc. I'm a solutions engineer there, so I'm running around doing all kinds of things like a chicken with its head cut off right now. So I spearhead the training effort, so I generate and manage a lot of the training content and also deliver it, help customers implement Docker, and also, involved with the sales and the sort of next steps of the product kind of side of things. And I'm going to actually be showing you today some of the existing kind of experimental things that some of us have been kind of hacking on in our spare time that we'd really like to see in sort of the next gen stage of Docker. So that's what I'm going to be showing you today. And then I'm also going to be showing a sort of a proof of concept demo of a rolling deploy, right? So it's a high availability deploy, or what some people call a zero downtime deploy. Now, zero downtime is pretty contingent on little hiccups not happening. For instance, yesterday during this demo, I was like, oh, and the server just randomly went down. That's great. Hopefully everything will go even better today. And I want to kind of start off by saying, thank you guys so much for coming. We really appreciate it. The level of enthusiasm and energy and excitement around Docker is just incredibly humbling. So really appreciate you guys coming out and taking an hour out of your day to come and listen to me talk about Docker and then demo some hands-on stuff, right? So the general idea for the presentation today is that I'm going to be doing a little bit of an intro to Docker so that if you're not really familiar with the problems that it's solving or with the underlying tech, you can get familiar. But I don't really want to spend too much time on that, since a lot of that information's easily accessible online, or you might have been just bombarded with it from everywhere. So the majority of what I'm going to be showing you and talking about and demoing is like actual hands-on on the command line stuff, where I talk about what's the sort of architecture behind the zero downtime deploy, and why is Docker useful for that? And then also, we're just going to get to dig right in and talk about a lot of juicy technical details. So, like I said, the agenda is going to be a little bit of an intro to Docker and then really demo heavy. So one of the things that is the reason that Docker is catching on right now, I feel like, is just it sort of really struck a nerve with people in the right place at the right time, because there's been this huge shift in the industry from applications which are deployed once to a single server, and they sort of sit there, and then they live there for all of their life, and they never really get changed. And your deploy maybe is like FTP some new PHP files up to the server, and maybe run a few admin scripts or something. And now we live in this world where all kinds of different random stuff is happening, right? So now not only do we have PHP to worry about, we have all variety of different backends in terms of data, right? So we have Elasticsearch and Solr and Lucene and all kinds of things in that arena, Redis and so on, that we have to manage, right? If you're a sysadmin, you have to manage that. And if you're a developer who is sort of wearing both hats, which is the formation of the DevOps space, then you also have to know a lot about that. And you get to manage it all, right? And so a big problem is sysadmins aren't developers and developers aren't sysadmins, right? So both sides have been sort of coming together into the middle lately and forming this new space that people call DevOps. Because the problem today is that we have all of these different things that we have to keep track of, right? You now have a variety of different language stacks, different application platforms, and you want to deliver all the time, right? I was just reading an article today about what's the overlying message of AWS Summit 2014, and they were basically talking about how a lot of the messaging is around agility, right? So previously, one of the big selling points of cloud computing was just cost, right? It's a lot cheaper to just use the cloud computing that's available to you than to build your own data centers and manage everything and, a hard drive is failing randomly and we don't know why, and then you get to go look and see what's wrong with it, like physically on a physical level, and it turns out that 3 of the screws for the hard drive were loose and now it's like jittering. And so cloud computing, takes a lot of that cost out, but more importantly, now it makes you faster, right? So a big reason why Docker is catching on, I think, is because it allows you to move a lot more quickly, right? One of the very common problem that development teams have is a new developer joins your team, and you need to get them set up with everything precisely tuned to the way that they need it in their environment to develop. Well, the way that historically things like that have gone is, well, you get them set up, and if you have good automation, they're at a good starting point. But also, they need to talk to the members of the team to get the tribal knowledge of how to actually configure their environment the right way, and so on and so forth. And so, maybe the one guy who knows how to set up the database properly is out sick or out to lunch, so it takes this new developer like days or a week to get set up just to start developing, right? Just to start contributing code. And there's enough things that are hard about joining a new development team as it is. We don't need to throw environment configuration in there too. So what we end up having is what we call the matrix from hell, right? So you have all these different environments, a dev environment, a place for QAs to test it, server that you want to run it on in prod, and you have all these different things that you might want to run, including an analytics DB, another DB, maybe a key value store, your actual application code. God help you if you have applications that are written in different languages or different paradigms, right? Because then suddenly you're juggling bundler and pip and npm and so on. And so you get this matrix from hell where you have all these different environments that you want to run something in, and all these different things that you want to run, and it looks slightly different in every place. And what Docker wants to do is solve that. So a little bit about the advantages of containers. They're a lightweight form of application-level virtualization that takes advantage of features that the Linux kernel provides for better process isolation and resource control, right? So it's not magic, right? So one of the things actually that I've been trying to sort of combat lately is people are kind of like, oh, well, it might just be magic. This is like a tendency that everyone has with all new technologies, right? Is that, oh, well, maybe it's magic and it can solve all of these problems and pain points that I have. And Docker is an amazing technology and it does a ton of things and enables things that just weren't possible before. But it doesn't fix everything, right? So what you need to know about containers is just they're a very lightweight form of virtualization that isolates processes off better than they were able to be isolated before, and also provides additional knobs and dials to turn to sort of control the resources like CPU and memory that those processes are using, right? And so, there's no hypervisor, right? So there's no virtualized kernel. We're not emulating hardware. We are actually using the host kernel, and we're just using features that the Linux kernel has been adding in since around 2005 to make this kind of thing possible. And additionally, in Docker's case, we introduced this sensible default of using a union file system to do images in layers so that we can use this little copy on write trick so that if you start, say, 5 containers that use the same image, you're only actually keeping that on disk in one place, right? So 5 copies of Ubuntu running, 1 thing on disk. So a big part of what Docker wants to do is we want to make containers easy to use, standardized, and interoperable, right? And we want to provide this whole ecosystem around it, right? Take a drink, because I said ecosystem. There was this joke on Twitter this morning where someone said, I actually wrote this new Firefox plugin where every time that you see the instance of the word Docker, it replaces it with a picture of a leprechaun riding a unicorn or whatever. And so I said, that's cool, but you should actually have a configurable menu with different cryptozoological creatures, so you could choose a leprechaun and a dragon and a unicorn, or whatever your preference is. They seem to like that. So the thing is that it really does matter, though, to have an ecosystem and a whole variety of existing things. As far as we carry the containerization metaphor in terms of comparing ourselves to actual physical shipping containers, the thing about actual physical shipping containers is that they're not just this box with standardized dimensions that's made out of weathering steel, right? They also have hooks and holes in all the right places, and all of the things that use them know to expect those. And so you get this whole ecosystem of stuff around it that knows to expect that particular thing. So then all of the cranes that use containers work the same way, and same thing with all of the trains that move containers around, and all of the ships that ship containers, and so on. And so they have this standard expected interface, and so that's a big part of what we're trying to do, right? Because if we can't actually get a real standard to work, then we end up with sort of like the XKCD standard is XKCD situation where we're saying, oh man, there's like all these 15 competing standards and they all suck. Well, we should make our own, and then we'll be the universal standard. Now there's like 16 competing standards, right? So what we would like to do is the sort of standard interface for, basically packaging up an application on steroids. And this is just sort of an illustration of how all the different aspects of everything feed into each other and continue to move on, right? So there's the Docker platform of engine and hub. Engine is the actual open source binary that you interact with on the command line, and hub is the software as a service component where all of the standard images live, and mostly that's where you push and pull from. And that feeds into the company of Docker Inc., which supports it and gives training and makes money off of stuff around the open source product. And then that also feeds back into the community so that the maintainers are able to keep going, maintaining the product, adding new features, one of which is a proposed feature that I'm going to show you today, and keeping this sort of virtuous cycle going. So you may have heard a little bit about this at the keynote yesterday. Basically, we like to talk about Guilt, one of our leading sort of flagship applications. This is exactly what we'd like to see happen for everyone. They used to have this huge, messy deploy process and ugly monolithic applications, and now they broke everything out into this Docker-centric workflow where they're able to move very fast, and dev to deploy is now hours instead of weeks. And I'm going to actually show you right now some instances of where, basically not only does Docker provide you flexibility in the form of the ability to roll back your application in case something goes wrong in a deploy, but it also allows you flexibility to just develop and deploy stuff really, really quickly. So I hope those slides didn't rot your brain too much. Personally, I'm not a huge slide fan, but they are handy. And so now I'm going to actually show you some of the real stuff of working with Docker. So, there's one more slide, which is a diagram to show you. So taking the whole site down to do a deploy is really painful, and we can do better. We have the technology. So what I'm going to show is a demo of using Docker to do a rolling deploy. So we're going to actually hot update the application in place while people are still accessing it, right, and using it. And so this is a little bit of what the architecture of what we're going to be doing looks like. We have everything hosted on EC2, so not only am I running the actual Docker commands from EC2 instance in the first place, but I'm actually communicating with a remote Docker daemon that's running on another EC2 instance. That's where our actual website is hosted in a container. We have a request that goes in through HA proxy, and HA proxy load balances out to two different backends, right? And then those backends are also connected to an instance of Redis so that we can persist data. And we're orchestrated with this amazing tool called the Born Again shell. Right, so it's pretty useful. I don't know if you've heard of it, but so I wrote this bash script to do a deploy, and you'll be able to get an in-depth look at it. And also, it's hosted on GitHub, so I can show you, where it's hosted. Actually, I can just go ahead and show you right now. If you want to look at the code for what I'm gonna show you, it's at github.com/NathanLeClaire/AWS-app, and fair warning, it requires sort of this, cutting edge feature of Docker hosts, which is still in proposal mode right now. It's part of the new sort of push that we've been having lately to provide better answers inside of Docker directly to orchestration, right? So if you want to run multi-container applications and connect them together and have them work together really effectively, how do you do that? And clustering, so if you want to be agnostic about where your applications are running and basically just say, run this, run this, run this, and figure out, let whatever the clustering management system is, figure out where they're going to run, which is actually a very hard problem. And Amazon's new ECS offering seems to be very promising in that direction. And then also around host management, right? So if you want to actually run on a remote host, right now that's sort of annoying to get set up. You have to use some sort of external tool, and we'd really like to be able to make it so that in Docker itself, you can just say Docker hosts create blah, 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 and it will say spin up an EC2 instance with Docker already running and everything provisioned the exact right way, and then just connect you to it, and you can just start running Docker commands in the cloud right away, right, very quickly. And I'm going to show you that, because I actually wrote the EC2 driver for that. So basically, right failed, broken pipe, SSH back in here. So I have this EC2 instance running, and I'm basically using it for development, right? So I developed the demo on this instance. And this is the application repo. And what I'm going to talk about a little bit is this feature called Docker hosts, right? So this is the first thing to kind of get your head around to understand what's going to be happening in the demo. So we have this command Docker hosts, and when you type Docker hosts, what it will show you is a list of all of the Docker hosts that you have running, one of which is the Unix socket, which is local, so that's the default host, right? So you could run Docker commands locally, but also Docker hosts makes it very easy to actually create and manage instances running Docker in the cloud, right, or inside of a virtual machine locally. So right now, if you want to use Docker on OS X, you have to actually use this tool called boot to Docker, which is a way of managing the VM so that you can expose a remote Docker daemon and connect to it from your local client, and then run Docker commands that way. And wouldn't it be nice if that was all just inside of Docker? And with this feature, it would be, right? We would have a driver for VirtualBox that allows you to just administrate that Docker instance that's running remotely in VirtualBox using Docker hosts. So Docker host has all sorts of commands, right, that you can run. So I'm going to go ahead and show you here what it's like to actually create a remote host. So if you do Docker host create, this is the command to create a new instance. And it's kind of hard to see the options, but basically there are all these options that you can pass as arguments so that you can specify, for instance, A, what's the driver that you want to use. We have drivers for Azure, for Rackspace, for DigitalOcean, for Amazon, and so on. And also, what are the configurable options, like the configurable parameters that you want to actually set? So you can set, obviously, your AWS account credentials so that you can actually authorize the creation of that instance on your account. But also, you can say what kind of instance type you want, what kind of region that you want to put it in, availability zone, and so on. And what's the image ID? So you can launch something from a custom AMI. So it actually also provides some options so that either you can have Docker pre-installed on an AMI and everything configured exactly the way you like it, or you can just let the default Docker host provisioning take care of installing and bootstrapping Docker and getting it set up the right way for you. So I'll make the text a little bigger so you can see. So the command to actually create a host is Docker hosts create. So we do Docker hosts create -- driver EC2. And I'm just going to say no install, since installing Docker takes kind of a second, but the default AMI has a version of Docker installed already, right? So -- no install, and then I'm going to give it a name, like Kaiju, I don't know. It's like, give it some weird name. So what Docker host create will do is it will actually use the security group that has the proper ingress rules that you need if it exists, and if it doesn't exist, it will create it. It will actually create a key pair for accessing that instance over SSH and store it locally, so you don't actually have to worry about managing the key pairs for that instance. That's taken care of for you automatically. It will wait for SSH to become available on the instance. Then once SSH becomes available, it will connect to that instance and remotely provision it over SSH, right? So it will install Docker if it's not already installed there. And if it is already, and then when it's finished with that, it will actually configure the daemon options the way that you need to set it up for remote connection, then restart the service, and then you'll be good to go. You can run Docker commands remotely against that host. So once SSH becomes available here, sorry about that, set the daemon options, restart the service to reflect the changes, and then bam, the host is tagged and created, and we can now run commands against the active host. Right, so you can see here now in Docker hosts, we have this other host, Kaiju, that was just created. So this is this brand spanking new host running Docker on an EC2 instance. So I could do something like this, right? I can do Docker run in detached mode with -p 80 to 80. So I'm forwarding port 80 from the container to port 80 on localhost on the actual host machine. and I'm just going to say nginx, right? So I'm going to run an image called nginx, and it will take advantage of our official repos that we have on Docker Hub. And it will actually pull nginx and run it. So then we'll be able to actually go to that website, right? We can go to that IP address, and we'll be able to see the nginx welcome page of, welcome to nginx. This is the default page, blah, blah, blah. And so when the pull finishes, we'll actually have a container that run, and it's a container that's running on a remote host. And you can think of this as something that's pretty cool and fun to play with, especially if you want to get started using Docker really quickly, or you want to use Docker on like coffee shop Wi-Fi where it's terrible. And so, the advantage of running on EC2 is pretty obvious because you can slurp down things on a huge, big, fat pipe instead of actually trying to slurp, everything down at Starbucks and having them hate you or put you off the network or whatever. You're just running over SSH. So we actually downloaded this image, and note how fast nginx booted up, right? So it's really, the speed is quite comparable to just starting a process natively on your host. So we have this container now that you can see. So you see Docker PS, it's this container that was named Trusting Fermi, right? And you can do stuff like Docker host IP, so give me the IP of the host named Kaiju, which is our new one, right? And so I can grab this IP address and actually come over and see this, right? So very easily, we spun up a totally new EC2 instance with everything already set the way that we want. And then we launched a container and ran it, right? So this is a basic feature that is a proposed feature out for Docker right now that is a big component of the script that I've written for doing a zero downtime deploy. You can also do stuff like Docker hosts SSH of the host and then run a command, right? So I could check how much disk space I have on that host with just one command, right? So it gives me the result of the command back. So that's pretty cool. And then likewise, you just have this sort of nice UI around actually managing the remote host. So Docker hosts rm Kaiju, now it doesn't exist anymore. I made an actual call out to the Amazon API to say get rid of that host. So that's Docker host, and so I'm going to talk a little bit now about how I'm actually going to do the rolling deploy, and then I'm going to do it, right? And so the way that the deploy works is I have this HA proxy configuration, right? So I have this HA proxy config, and the first two blocks look pretty normal. There's just some default like timeout settings for HA proxy, and then there's a front end that says, okay, we bind to 80, right? We bind to the external port, and then also, okay, proxies these requests to the back end, right? And so the back end is a load balancer that uses the round robin algorithm, so it will just dispense requests out to the nodes one at a time. And I have two nodes, right? One is a container that's running a server listening on port 8000 locally, and the other is a container that's running a server running on port 8001 locally. And we'll actually dispense requests out to those in a round-robin fashion. And when we're going to actually take one down to do a deploy, what we do is we just set its health check status to down so that HA proxy will start continue querying it once per 100 milliseconds. And so the node will self-report as being down. So HA proxy will actually take it out of the rotation, but it will continue serving requests until we actually stop it and kill it manually ourselves and remove it and then start a new one, right? And then then the new one will actually start responding to requests, so HA proxy will put it back in rotation. And the point of this is that it allows us to do a hot deploy, right? So we can actually deploy applications without any downtime. And I'm almost just endangered the entire thing here. Actually, I don't think I would have. HA proxy doesn't get redeployed every time. It's just like a thing that happens when I spin up the infrastructure for the first time. So the script to actually run this is deploy.shell. And so basically what we do in a deploy is we set the Docker hosts active to default, right? So we actually say, all right, we're going to run some Docker commands locally, and then we do this little command called push tagged image. And that's just a function that builds the Python image, and then it pushes it out to the Docker Hub. And then we say, okay, now after that, when we're doing a deploy, we set the active host to the remote host that's running, which is called AWS Lightning Fast. And then we do a pull of that image down from Docker Hub, and then we run app containers from image, right? So run, whoops. app containers from image is this little function which will loop over every container that I have running, and it will report the health as bad, so HA proxy will actually take it out of rotation, and then it will Docker stop that container, Docker remove it, and then it will start another container with the same properties using the new image, right? So each image that we deploy out gets a certain tag, and the reason that's important is because that way we have every single image that we've ever deployed tagged with a unique tag, and it could be a git SHA. In this case, I just use a timestamp for simplicity. And the reason that that's important is because if we do a deploy and something goes wrong, we could just very easily roll back to a known good state, and I'll show you that. So all right, without further ado, we're going to do like 4 deploys. So let me first make sure I didn't actually fat finger something here. Aha! I did. So just check this out. So yeah, so yesterday I made this change. I love you aws-reinvent and deployed it, right? And you can see if you go to the IP address here, this is the deployed app in production, right? So you can see that I have this hit counter so that every time that you hit the website, the little Redis counter goes up, right? And so, well, what if we want to actually do a deploy with 0 downtime? Well, I can use this little one-liner that I have for like a health check, and I'm going to make the text actually slightly smaller. And oh, I need to SSH again. So I have this little health check one-liner that shows us basically the status of the service responding or not, just in one line. And so this website says, I love you aws-reinvent, but we could change it to say something else, right? Like, I love you more aws-reinvent session 2, right? Like, so edit it. Add an exclamation point for effect. And so we can do, now we're going to run our deploy script. So what's happening here is we rebuild the image. So now we have the new app code baked into a new image, tagged with this timestamp. You can see at the top here it says Friday, November 14th, 192707. Well, we're just tagging that instance of that image with a timestamp so that we can actually refer back to it later if we want to like roll back to that image. And we're pushing it out, right? And the push goes pretty quickly considering the size of the image, because all of the image layers that we've already pushed, we just call it to Docker Hub and basically find out, okay, well, we've pushed it already, so skip over it and don't need to push it. And image pushes are, considering the size of an image generally, right now are decently fast, but they're going to get even faster because right now we're basically working on a rework of the registry and the image process, right? And so now we're restarting the container, and you can notice here that you see over here in this little health check that we're hitting the home page, but everything is still going on, right? So this is actually surprisingly tricky to get right because, for instance, if you regenerate the load balancer config and then restart the load balancer, well, guess what? You have a temporary like little moment where your load balancer is down, and then guess what? You're not 0 downtime. So I'm pretty happy right now, actually, because yesterday there was some weird hiccup and the deploy didn't work. Well, the deploy worked, but there was downtime. So you see, I love you more, aws-reinvent session 2. Don't tell the other session, and they might get jealous. And that's pretty cool. We updated the template that Flask is using. But I wanted to show something slightly more sort of, like a little bit more like remarkable. And oh, it looks like my terminal done froze up on me. Just re-SSH in. And that's what we're going to show is we're going to actually show switching over to a branch that uses Tornado to actually serve up the requests instead of just the default Flask server, right? So basically, you can see here that I've made this commit where there was a change where I moved over to using Tornado instead of the default Flask server. So in case you're not familiar, Tornado is this Python package that allows you to use an evented server to serve requests faster because it takes advantage of epoll and stuff like that. So So basically, now we switched Git branches, so we want to do a deploy of our new code, right? And so we're going to see like the same kind of thing running, right? You'll notice that as the image is building, we're actually remaking the image so that it has like a pip, like it basically rebundles all of the pip packages in that layer because we actually added a new one, right? We added a new one to requirements.txt, which is called Tornado. And so now Tornado is being bundled into the image, and the same thing that was happening before is now happening again, right? So what you'll see is when the containers actually start rebooting, now pay close attention to this little thing in the second pane here where we have, it says HTTP 1.0. When the Tornado server actually starts and the containers behind the load balancer actually start serving requests using Tornado instead of using the default Flask server, this HTTP 1.0 will actually switch from 1.0 to 1.1, right? This is like kind of a nice accidental thing where I don't know why Flask by default is HTTP 1.0 and Tornado is 1.1, but it's kind of interesting should be about right now. So it's kind of interesting to actually watch this happen as the deploy is going on, right? You can see that the requests that we get back when we're actually hitting the server go from 1.0 to 1.1, right? So right now it'll start happening, boom. Yeah, so that's pretty cool, right? And actually it might mix or it might not, right? The requests in place, but the point is that we're only ever hitting the server that's actually up. And so we actually just switched our application over to use Tornado without any downtime, right? So the app was successfully deployed, and you can come over here and hit it, right? So there's been 34,000 hits on our awesome MVP website. And so, okay, that's pretty cool. That's all good and well, right? But what if our application developers did something forbidden, like actually having 5 spaces of indentation instead of 4 in one of their Python blocks, and then they did a deploy. Suddenly, the website's down, we're losing money, and everything's on fire, right? So traditionally, if we were using some sort of other way of deploying that, well, we have a big problem on our hands, right? So we have a big problem on our hands of, okay, we deployed stuff, we don't exactly know what went wrong, and we don't have any real way of rolling back to a known good state. The only way we have is to keep going forward, right? We pulled a switch that we can't go back on. So what I want to show you right now is an example of how Docker can help with that, right? Because you'll notice that I pointed out earlier that we actually have these, Tmox is like freaking out. All right, here we go. So we have this image tag, right? So, okay, we deployed the Tornado server, everything's going great, we're super happy, but then at 2 o'clock in the day or whatever, our developers did something like this, which is really stupid. Right, they went, okay, I'm just going to make this awesome change to the main function, right? And so, yes, I added a space. I'm awesome. And so Josh, the developer, sorry if someone in the audience is named Josh, but I just picked Josh because it's a common name. So Josh, the developer, says, oh, yes, Docker allows me to do frequent deploys. It's awesome. So I'm going to push out all this awesome new code, right? And so I push out the code. So we're going to do a deploy again, right? So this is like the 3rd time that we've deployed in this demo. So you'll notice that what's going to happen now is instead of those, I was like, pay close attention to the HTTP header, right? This little loop over here in the side pane is just basically showing a timestamp and the status of what is the header that the home page returns for every 200 milliseconds, right? So I'm hitting the website every 200 milliseconds. And so we pushed the image out to Docker Hub. Now we're pulling it back down in the website. And then we're going to actually start the deploy, right? So we're going to start deploying Josh's terrible code. And notice what happens in the second pane over here, right? So we start deploying Josh's terrible code. The load balancer is doing its thing, faking out the health checks, making sure that we don't, what happened? Josh pushed out some code that broke everything. That's what happened. And so, okay. Well, different organizations take different amounts of time to actually pick up on something going wrong, and it may not be as obvious as this, right? But it may be something that's like, how many times, hands up, like how many times have someone in here ever done a deploy or been a part of a deploy where you finished it and, basically everything was completely broken? Anybody? Yeah, that's a lot of hands. That's a lot of hands. So, wouldn't it be nice if you could just roll back to this sort of known good state, right? So you'll remember that we actually kept track of that. We kept track of that image tag, which I seem to have lost in my clipboard, but I can just scroll back up and get. So the one that we knew was good, right? This is the last one that we used that was good, where we could just do this, right? So what if we could just do /deploy.shell rollback, and we gave it this tag, right? And then we actually run these remote Docker commands, and we say, OK, bring it back to the known good state. Boom. Everything's back up, back in the state that was good, right? So now we just make Josh wear a dunce cap and sit in the corner and write, I am a terrible developer, or sysadmin, or whatever, over and over and over again. And meanwhile, we can actually, another kind of awesome thing is like this tag, right? So this tag that we deployed that we know was bad, right? Like, we know something went wrong. Fortunately, we're using Docker, so a rollback was really super easy. But we still need to debug it, right? We still need to keep moving forward. I mean, we fixed the site for now, so we kind of got the fire contained. We need to figure out what was going wrong. So you might actually be able to do something like this, right? You might actually be able to say docker run -it of that image with that tag and say it's bash, right? And then we actually get this shell with this exact environment where the problem happened, and we could, go in and poke around and debug it a little bit, right? So we could do something like look at the file and say, oh, I see what the problem was. Josh added an extra level of indentation here, and then we could come back over to source control and fix it, right? Now we can actually, have a successful deploy, right? It's a VI of app.py here. Oh, okay, fix the problem. Boom. Now deploy the new thing, right? And then all of this happens seamlessly, right? So nothing gets interrupted, no interruption of service. We're not losing money, right? We're not having a website that goes down. And, I don't mean to trivialize this as a technical problem. Like doing hot deploys is really hard. I know because I worked on this demo for a long time, and it's trickier than it looks. Because the problem is that you always have this little, you always have one thing, which is a possible point of failure or like a race condition where stuff could go wrong. But I think it's like a huge step in the right direction, right? Because really the kind of holy grail is we could just push out code at any time that we wanted, and we could really iterate super fast and super agile and just push out and deploy code whenever we wanted, and developers could be agnostic about the actual thing that's running their code because, as many of you may know, developers usually don't care about, like, I don't care what runs my code, just run it, right? And so we're doing this deploy right now, and everything's going swimmingly. I'm very happy because there was a weird issue with my thing yesterday, and I was like, I blame you guys. Actually, like, I think that I didn't know if it was just like a lot of load and the Flask server went down or something, but something went mysteriously wrong yesterday in like a part of the deploy that isn't even when I take the container down, so it was probably unrelated, honestly. But yeah. So now we deployed everything, and everything's going awesomely. And you could access this website if you want. It's running for real, right? I'm not faking you out. And so you could go to 54.87.38.100, and you'll actually see, welcome to the lightning fast deploy MVP. Contact sales@docker.com to give us some money. These are all the things that we sell, so shameless self-promotion there. And yeah, so that's mostly what I had to show. In case you're curious about the rollback stuff, it's literally just a few commands, right? So rollback is just, okay, set the active host to the one that's running remotely, which is like our prod server, right? And then run app containers from image, which is that little function, if you recall, to actually loop over all the containers that we want, which is just 2 in this case, and then set the health of them to go down, then stop them, restart them, right? And then we just set the active host back to default, right? So we run app containers from image with whatever the tag is that we passed in, and we do a rolling deploy with a rollback back to the sort of known good state of the application. So let's see. That's about all. I'm happy to kind of take any questions. I really appreciate you guys coming, and I'm super excited about Docker, and I hope that sort of stimulated your imagination and made you guys excited about stuff too.